we left off yesterday talking about the even and odd functions, and now we're going to evaluate sine and cosine using the period. So remember, the period means how long does it go before it starts repeating. So if you think about this, sine will go from 0 all the way around, and none of these are going to repeat. These points are all different, right? But if you think about, and cosine is the same, it goes all the way around. But tangent is when you take an x value, or the y value, and you divide it by the x. So here I would get positive tangent, positive tangent, positive tangent, right? Negative, negative, negative. But here, I'm back to getting the same positive values when I divide these. So tangent only goes from 0 to pi, and then it starts repeating again. So sine and cosine have a period of 2 pi. Tangent has a period of pi, and we'll get into that more when we start graphing them. So if we are trying to evaluate what the sine of the angle 13 pi over 6 is, if you look at your unit circle, you do not have a 13 pi over 6, right? But if I count it in increments of pi over 6, which is the 30 degrees, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 5 pi over 6, 6 pi over 6, oops, I missed one. 1, 2, 3, 4, 5, 6 pi over 6, 7, 8, 9, 10, 11, 12 pi over 6, 13 pi over 6. And I'd be right back here again, right? But if I were to take my 13 pi over 6 and do what we did when we found coterminal angles, we could find an angle that's on our unit circle. So I could take the 13 pi over 6 and say, okay, well, I know that that is bigger than 2 pi. So therefore, I'm going to take away 2 pi. And if you actually do that in the calculator, you get pi over 6. So if I want to know what the sine of 13 pi over 6 is, that's the same angle as pi over 6. So I would grab my unit circle and look at pi over 6, and the sine value there, which is the y, is 1/2. All right, same thing with your 7 pi over 2. Now, this is negative, so we'll have to count backwards. But if you were thinking about where positive 7 pi over 2 is, pi over 2 is 90 degrees, right? So that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, which is the same angle as this angle right here in the positive direction. But I want to go negative 7 pi over 2, correct? So I would be going backwards. But instead of just counting and counting and counting, I could just add 2 pi to that. So I'm going to add 2 pi to the negative 7 pi over 2. When I put that in and I press enter, I get negative 3 pi over 2. So I'm still not at an angle that I recognize on my unit circle, right? That means I've gone more than one revolution backwards. And if you think about that, if you went backwards 7 pi over 2, that'd be 1, 2, 3, 4. That's 1 all the way around, right? 5, 6, 7. So if I were to subtract one more time, I should be at pi over 2 here. Let's see if I'm right. So I'm going to go ahead and add another 2 pi. And I end up at pi over 2, which is what we said when we counted round backwards, right? That's the same angle as pi over 2. So if you look on your unit circle, you're trying to find the cosine of pi over 2, which is your x value. So the cosine of pi over 2 is 0. So now we're going to throw in sine of a negative angle. Now if you look up at your even and odds, if I take the sine of a negative angle, that's the same thing as the negative sine of that positive angle. So this is telling me, okay, given that sine of this angle is 4 over 5. They want me to find sine of the negative angle. Well, it just said that the sine of the negative angle is equal to the sine of that positive angle, but with a negative. All right? So you're just going to make yourself a little equation here. You know that sine of negative t, and think of it like this, is equal to, see how this part looks like the other side of what they just stated up above? Sine t, but the negative version of that? Well, you already know what sine t is. Sine t is 4/5. So you're equal to the negative 4/5. And then you're done. All right? So I want to find the cosine of 9 pi over 2. So 9 pi over 2, not on our unit circle, right? I would have to count around 9 altogether. So that would be like 1, 2, 3, 4, 5, 6, 7, 8. That would be 9 pi over 2, right? So I went around a bunch, right? 1 revolution, 2, like 2 1/4. So I'm probably going to have to subtract more than just 2 pi, correct? So I'm going to go ahead and take away 2 pi, and we're going to see that that's not enough, okay? I want to get to an angle that is on my unit circle. So I've got 9 pi over 2 minus 2 pi. But 5 pi over 2, still not on my circle, correct? So I didn't need to take away just 2 pi. All right, so I'm going to take away another 2 pi. And now I'm back to something on my circle. So instead of taking away 2 pi, I actually had to take away 4 pi. It was just too big to get back to what was on there. So I take that away. That gives me the cosine of pi over 2. And the cosine of pi over 2 we just found up here, correct? Which is 0, the x value. All right. Sine of negative 7 pi over 3. Well, I'm going to go ahead and change this to something else. I know I'm going to have to add pi, right? 2 pi's, because this is a negative angle. So I'm going to take that negative 7 pi over 3, and I'm going to add 2 pi. And I may have to add more than that. We'll just have to see. So negative 7 pi over 3 plus 2 pi. All right, plus 2 pi is not enough, right? But I'm going to add another 2 pi to bring me back another whole revolution, and I get 5 pi over 3. So now I'm going to be looking at the angle 5 pi over 3. Look on your unit circle. 5 pi over 3 is right here. The sine value is your y value, so negative square root of 3 over 2. All right. On part F, they want you to find cosine of t given that cosine of negative t is equal to 0.3. Well, if you look at your even and odd functions, it tells you that the cosine of a negative angle is the same thing as cosine of the positive angle. So they would be exactly the same, correct? So cosine of t would be equal to 0.3. All right, so now we're going to do this using a calculator. So first thing you want to make sure on your calculator is that you are in radians. You can tell that from up at the top. It should say rad. If it doesn't, you want to go to mode, and you want to change that to radians. Now, if I'm taking like the cosine, sine, tangent of degrees, then I would want it in degrees. This is one of the things that people get tripped up on the most, is they'll be in the wrong mode. So you have to tell your calculator if you're putting radians in or if you're putting degrees in. So if you look back here, all of these are radians. even this is a radian. And I know that because it doesn't say degrees. So if it had the degree symbol, then I would want to make sure that I'm in degrees. But since it doesn't, all of these are radians. So I'm literally just going to plug this in, sine of 2 pi over 3 in my calculator. So sine, which is right here, 2 pi over 3. And it tells me that that is the square root of 3 over 2. And if you actually look on your unit circle, if you go to 2 pi over 3, which is right here, the y value is square root of 3 over 2, right? Your calculator is just really smart. All right. So then B, cotangent of 1.5. So here's the deal. Cotangent is an inverse. So in your calculator, you're not going to put tangent or anything. You're not going to put cotangent. There's not a button for that. You have to do 1 over tangent. So you're going to use whatever the inverse of this is. So if it was cosecant, then we would use sine. You're going to do 1 over tan of 1.5. And you get 0.07. We'll just round to 2 here. Okay, so part C, sine 5 pi over 7. Five pi over 7 is not an angle on your unit circle, correct? So it's not going to give you that pretty, fraction. So 0.78. And then we don't have a button for cosecant because that's an inverse, but that's the inverse of sine. So we'll do 1 over sine 2. You don't have to put the 0.0. And you get 1.09, so that would be 1.1.